Hello, everyone. This is the lecture for section 1.2, domain and range. Okay, so in section 1.1, we learned how to write out a function and how to evaluate using functions, learning how functions notation works out. Now we're going to get into a little bit more of the analytical portions. We know what a function looks like, right? We know what an input is. We know what the outputs are, right? In our travels, we might find functions that we may or may not be able to plug in every single number we can think of. Okay. Um, and in order to denote that, right, that's why we have to be very cognizant about what the domain of a function is and the range of a function is. Okay. So before we do that, okay, we need to first start by defining a couple of things. And that thing that we need to define right now is what's called the interval notation, okay? In defining domain and range, right, we're going to need to be able to denote sets of numbers, okay? And the way that we do that is by this thing called interval notation, okay? So to show you guys how to do it, okay, let me scroll down to our table, okay? And it's got a picture there. The only column that's empty right now is interval notation. That's the column that I'm going to be filling in, okay? So let's start with the first two, this one and this one. Suppose that we want all the numbers bigger than a value A, okay? Suppose that we want the X values that are bigger than a value A, okay? And I need to stick this in right here. I'm going to put it in right here. Strictly greater than A, okay? So let's say we want all the numbers, for example, right? All the numbers bigger than 3. I don't want 3. I want every number bigger than it, okay? Then this is the notation for it, okay? Then we would do A, comma, infinity, okay? And if you take a look on the number line, right? It starts here and it goes off that way, right? But we don't take that value. That value is not the one that we want, okay? Likewise, if we want all the numbers less than A, right? We do the exact same thing, but backwards. Negative infinity to A, okay? So that one works the same way. Starts here, goes all the way backwards that way, right? But we don't take that X equal A value, okay? Okay, let's move on to the next two. This one and this one, okay? Now in this case, in these two, we do want that value A. Does that make sense? So if we want to write these sets of numbers, right, then we would do this. A comma infinity, negative infinity, comma A. And notice how I'm denoting that I do want the A value. It's me using that bracket, okay? So in this case, this value right here is included, okay? Now, hopefully you guys see a pattern, right? In the way that we are using the parentheses, right? And the brackets. Got it? And the overall rule, right, here, hopefully you guys found this out already, is if you use the parentheses, you don't include those numbers. And if you use the hard brackets, you do. You do include the numbers, okay? And that's practically it. That's what people tend to remember when they need to do interval notation. So now let's go ahead and do the next two. Suppose we want all the numbers between A and B, right? Let's do the first one first, right? Suppose we want all the numbers between A and B, but we don't want either side. We don't want A or B specifically. We want everything between A and B, but not either of the endpoints, right? The way that we would write this out would be this. A comma B. Okay. Next one down. Suppose we want from A to B, but we do want to include A, but don't want to include B. Got it? Okay. Easy enough, right? So I want A, but I don't want B. Since I don't want B and I do want A, bam, done. Okay. Let's take the last two, vice versa, right? Let's say I don't want A, but I want B. A to B. I don't want A, but I do want B. All done. And then the last one. Suppose I want both ends, right? It's still A to B, but in this case, bam, and bam. I'm going to use the brackets on both ends. Okay? All right. So now that we know how to use interval notation, this was a means to an end. We are actually going to be doing something else with it. Okay? So, like I had explained before, right? Um, now that we know how to use functions, right, we may come across functions that we cannot plug in certain values. Okay. What I mean by plug in certain values is that a value cannot be an input to a function. Okay. So we have to be cognizant, like I said before, of what the domains of our functions are. Okay. And that's the primary topic of this section. We're going to be looking for the domains of functions. Okay. And this sort of comes back to, at least this is how we're going to be learning it, at least for now. Okay. Um, this goes back to a couple of rules that you probably remember from grade school that you can't do in math. Okay. The idea behind finding a domain for a function, right? Like I said, the domain, right, is the collection of all the possible inputs, right? So that's what we're looking for. We're looking for the collection of all possible inputs for a function, okay? The idea is not to go out and find all of the values that do work for a domain, right? Instead, what we do is find the numbers that don't work, kick those out, and everything else is fair game. Okay. And that just so happens to coincide with these rules that you probably remember from grade school. Okay. So let me cover the two rules that you probably remember from, kindergarten, middle school, high school, whenever the last time you took math was, right? Okay. So the first one, let me go number one. Okay. The first one, let me write out the words first, right? Tor equal to 0. So hopefully you guys remember this one, right? When you look at a fraction, right, there are two parts. There's the numerator, the top part, and there's a denominator, the bottom part. Okay. Uh, the denominator cannot be equal to 0. Okay. So basically saying, right, this is the rule that people remember, you can't divide by 0. Okay. So uh, if we have something that looks like we're going to be dividing by 0, we set the bottom, we set that denominator equal to 0. Find those numbers, kick those out. Okay, let's move on to number two. Okay, the second one is the way that I have it written is more general. Okay, the thing that people tend to remember as something that they can't do in math is that you can't take the square root of an the square root of a negative number. Okay. If you have a -4 and you have to take the square root of it, you can't do it. Okay. The more general statement of it is you cannot have a negative inside of an even root. You cannot have a negative inside of an even root. So the way that we look for domains using rule 2, right, is we grab the inside, right? and set it equal to 0, and then find everything that's negative. Okay? And then the last thing, right, when we want to express domains, right, we want to express the domain as an interval or intervals, okay, and excluding any restrictions that we found from 1 and 2. Okay. If there are no restrictions, if we can plug in everything under the sun, if the function that we're playing around with, right, doesn't divide by 0, and there isn't any negative inside of a square root, then what we have, right, is a domain that is all real numbers. So we can say that it is from negative infinity to infinity. This says that the domain is all real numbers, okay? And I just sort of semi gave it away just now. So the idea for looking for a domain, okay, uh, is you cannot divide by 0, and you cannot have a negative inside of an even root. Okay, so that's what we look for. We look for all the numbers that make us divide by 0, and we look for all the numbers that make us take the square root of a negative, kick those out. Everything else is fair game. Got it? Okay, that sounds a little weird, okay, but let me do some examples so I can show you guys what I'm talking about, okay? So for example 1, let's take this function right here, okay? And we're going to go down the list. Number 1, okay? Looking at this function, does it look like we are going to be dividing by 0? There is no division present, so there is no divide by 0. So no division, right? So therefore, no divide by 0. 2, looking at this function, does it look like we're going to be taking the square root of a negative number, or the square root or the even root of a negative number? There is no square root present, so this one produces no restrictions either. There is a square, not a square root. They're two different things. Just keep that in mind. Okay, so this one has a square, but that's fine. It's the square root that's the problem. So there's no square root, right? So there's no square root of a negative number. We are done. We checked number 1 and number 2. Neither produced restrictions. So for this one, the domain is going to be negative infinity to positive infinity. And we are done. Okay. So in this case, it doesn't seem like there was, well, there are no restrictions, right? This was a simple case. Let's move on to the next example, okay? Find the domain of this function right here. So now we're looking at this one, okay? So let's go through our list again. Number 1, we need to look for all the numbers that divide by 0, okay? In this case, okay, there is a division present, so we have to find the values that make us divide by 0. So hopefully just looking at it, it'll make you think, you know, what numbers can I divide by 0 that make me divide by 0, right? It looks like positive 2 would do it. So if I do 2 minus 2, right, I get 0 on the bottom, right? Okay, if you look back at the notes from above, right, you notice that I said make the denominator equal to 0. So let's go ahead and do that. This is the process to go ahead and do it, right? 2 minus x is equal to 0. So I'm going to solve for x like I did in kindergarten, right? So minus x is equal to minus 2. And if you divide by the negative, you get x is equal to 2. This is the number that we said is not good, right? So x equal to, whoops, makes us divide by 0. So if we have x equal x equal 2, that will make us divide by 0, right? Hopefully you guys see that. Okay. Number 2. Number 2 says that we can have the square root of a negative number, right? In this case, only a division is present. There are no square roots. So no square root, right? So then therefore, no square root of a negative number, right? So this one produces no restrictions. So the only number we are restricted to not plugging in is this one right here. This is the x equal 2 that we found from step 1. So now we are going to have to write this in terms of interval notation. Okay, so what I'm going to do is this, right? I'm going to do a number line right here, so to show you guys what I'm trying to talk about. Let's put 0 here. I'm going to put 2 here for that 2 right there. Okay, I want everything above going this way and below going this way, right? But I don't want the value 2. Got it? The way that we would write that out is this: negative infinity, comma, 2, union 2, comma, infinity. Okay, notice in the way that I wrote my domain, right? This one is all the numbers bigger than 2. This one is all the numbers less than 2. Okay, and both of them together do not have the value 2. So this is skipping over the number 2, right? So this set right here is all the numbers, but it's missing that value 2. All right, cool. Okay, let's pick up the difficulty a little bit. This one. Find the domain of a function. That one right there. Okay. This one right here. Okay. So if you take a look, right, let's go through our list again. Number 1. Number 1 says no divide by 0. There is no division here. You guys see that? There is no division. No division. This one doesn't have us divide by 0. So no division. I'm just writing that out. So therefore, no divide by 0. That's it. This one does not produce restrictions. Okay? This one does not produce restrictions. Number 2, there is a square root in this one. You guys see that? Okay, so since this one has a square root, I want you guys to notice something. If you remember from the previous section, we could do a diamond method on that thing, right? So I'm going to go ahead and do my x, right? Times on top, plus on the bottom, minus 36, minus 5. Okay, 2 numbers that multiply to negative 36 and add to negative 5. Okay, those 2 numbers are negative 9 and positive 4. Okay, so what we can do is this now. X squared minus 5x minus 36 is now also equal to x minus 9, x plus 4. So up until now, right? Up until what we just did, right? We know something special happens probably, right? Between, negative 4 and positive 9. Okay, so what I'm going to do now is I'm going to do a split screen here. So follow what I'm doing here, okay? And I'm going to go ahead and split it in between our notes and Desmos, okay? You're more than welcome to use Desmos for anything that we need to do here to sort of, what I'm trying to show you guys is not only the sort of mathematical wrote out part, but also the visual analytical part. Both tend to happen at the same time, okay? So what I'm going to do is I'm going to stick in x squared minus 5x minus 36. Okay, I'm gonna, hopefully you guys see what's happening. You guys see, this is the red portion right here. That is our function. This right here is our function. Okay, and what I want you guys to also notice is boom, boom. There is nothing between -4 and +9. Okay, and I want to sort of show you guys something really quick. So let me show you what happens at exactly x equals 0. So at, whoops, at x equals 0, you guys will see something here. I'm going to do the square root 0 minus 9, 0 plus 4 is equal to the square root of -9 times 4, which is the square root of -36. Okay? This we cannot have. This, remember, this is one of those no-no things that we can't have, right? And if you do that with every number between -4 and 9, you'll see that all of your answers will be negative inside of that square root. So between -4 and 9, there is no graph, right? This is how we see what the domain is graphically. Does that make sense? So we can say, right, because of all of this, right, between x equal -4 and x equal 9, right, we have the square root of a negative number. That we can't have. Okay? Cool. So now we know what we need to eliminate. We know the numbers that we cannot plug in, right? Everything else is fair game. We have to get everything between -4 and 9 out of there. Everything else is legit. Okay, so for this one, if you guys take a look at the graph, the graph sort of gives this to us, right? The domain of this function is going to be -∞ to -4, and I'm going to leave that there for now, union 9 to infinity. Okay, so you guys see that there is a graph. There is a graph before -4 and after +9. Yeah. So now the question is, do we include -4 and do we include 9? Right. And if you take a look, right, I'll invite you to do it on your own. If you plug in -4 and +9, you get the square root of 0. And the square root of 0 is 0. That is a valid number. So that means we can include those values. They actually work. Okay, so this right here would be our final answer. This is the domain of our function. Okay. All right, so let me go ahead and maximize my notes again. Let me move this back over right there. Okay, so now I sort of alluded to this before, right? In our previous example. There is one of the easier ways to find domains and ranges is to graph it, to look at the graph of a function. Okay. To analyze and find the nitty gritty, right? To justify why certain values can and cannot be included, that's where we have to do the numerical thing. That's where we have to do the rule number 1, the rule number 2, the divide by 0 or the square root of a negative. That's when that comes. Okay. But if you just want a gross like explanation of a domain, the easiest way to do it is by looking at its graph. Okay. So let me take a look at this function right here. So I'm going to be looking at this graph in particular. Okay. Notice there is no function for this one, okay? But we're going to need to find the domain and the range, okay? So just keep in mind, right? The domain of a function is all the inputs, and the range is the set of all outputs, okay? So if we look at this function that's on the left, okay? The domain first, right? Uh, Domain. How did I do domain before? Ah, okay. It's hard to do the cursive D sometimes. You know what I'm saying? D, there we go. Oh, okay. Domain. We are looking for all the inputs, the X values, right? So if you take a look, it starts here and it ends here. This entire graph, right? I'm looking only at the X values for the domain, okay? So you guys can see that it's basically all of this, okay? Moreover, if we take a look at this point right up here, you guys see that that point is filled in. So that means it actually hits the X value -5, okay? This is sort of a little bit of, I guess, nomenclature in terms of how to do graphs, right? When you have an arrow, it just keeps going in that direction. So we can expect this to be near vertical on the other end, okay? So there is an assumption I'm going to make here that it is approaching X equal +5, but it's never going to hit it, okay? So my domain here will be this. The lowest X value for this function is -5, and the highest will be +5, but it doesn't hit it. So bam. So our domain is done. Okay, next one, our range. Our range is the set of all possible outputs. So in this case, I'm looking at my Y values, okay? So let me get rid of all this. There we go. I am looking for my Y value. So I'm looking at, it looks like it starts about right here, okay? And it goes all the way down. And if you guys notice, this arrow tells you that it keeps dropping down, right? Okay, so when we look at the range, right, we are looking at the Y values. That arrow is telling us it keeps dropping down all the way down, 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 down. So the lowest this function can go looks to be -infinity. Let me write that right. -infinity, okay? And the highest it'll go is to +5. And since we can use the same logic that I was explaining just before, since that is a filled-in dot, it hits +5, okay? So that would be my range. So my domain and my range would be this, okay? Something that to keep in mind, right? And this is just, how would I say it? This is by convention, okay? I'll probably explain what the convention is during class. When we write interval notation, we want to do it from the negative values to the positive values, okay? So always start with the lowest negative value, right? And always go to the positive highest value, okay? Like I said, it's by convention. That's how we do it. Um, yeah, okay? Let's do one more looking at it by graph, okay? Let's take a look at this one. Find the domain and the range of the graph to the left. Okay, so let's start with our domain first. Okay, remember, domain means X values, right? It looks like it starts about here and goes to there, and all my X values should be everything in between. Okay, So the endpoints, you see that one that's not filled in compared to this one that is filled in? So the not filled in one means we don't include that one, okay? And the filled in one means we do, right? So we have our x values being from -3 to 1, right? Since -3 has the open dot, I don't want that one. But since 1 has the filled in dot, I do fill that one in. So I want the hard bracket there. Done. That is our domain. Okay. Range. Range looks at y values, right? So it looks like it starts here and it goes all the way down to about right there. So it should be all these values in between. Okay. So it looks like it's going to be 0, whoops, the other way around. See? -4 to 0. -4 because it starts right here, down here, and it goes all the way up to right there. Okay, so now you guys see this. This is filled in, right? So it looks like -4, we do want to include it. Okay, but this one is not filled in. However, this is something that catches people off guard. I want everybody to take a look at this point. This is another assumption I'm going to make, that it is going to go through 0, 0. So, and in this case, right, since my output is 0 at one point, okay, even though, even though this one is not filled in, right, my graph does go all the way up and hits the value y equals 0. Okay, so and that means 0 I will include. So don't only look at, so I guess moral of the story here, right? Don't only look at these points, right? The end points of the graph just because they're there, right? You have to look at the entire square, the entire gamut in between both of the endpoints to determine the proper domain and range for your function. Okay, keep that in mind. Uh, just just watch it. Just watch it. Okay. I think besides that, lecture questions come up next. Okay. For the quick checks, we'll do those in class. If there's any questions on this, ask me during my office hours, during class time, or find me in the math lab. Okay. All right. Besides that, happy studying.